AB and CD are two chords of a circle meeting at a point P. Then PA into PB is equal to PC into PD. This is known as secant property of a circle, right? It is a very important property that, let us say this is a circle and I am talking about these two chords AB and CD, and these two chords meet at a point P. These can meet like this externally at this point P, or there can be another scenario where these two chords AB and CD meet inside the circle. AB and CD meet inside the circle at this point P. In both these cases, PA into PB, PA into PB is going to be equal to PC into PD. And in this case also, these two product of these segments PA into PB is going to be equal to product of these segments PC into PD. How do we think about it? We will use the concept of similarity, right, as well as one more concept of cyclic quadrilaterals. Let me just show you. If I join this AC and BD, right, and think about these two triangles, triangle PAC and triangle PDB, right, triangle PAC and triangle PDB. Angle P is common to both these triangles, triangle PAC and triangle PDB, right? Another thing that you can notice that this angle here is an exterior angle for this quadrilateral, which is a cyclic quadrilateral, right? So this angle, if this is alpha, it will be equal to interior opposite angle, that is this angle. This angle will also be alpha, right? This angle is common to both the triangles. This angle is equal to this angle because this is an exterior angle to this cyclic quadrilateral, and it will be equal to interior opposite angle. Similarly, I can talk about this angle. This, if this is, let us say, beta, this angle will also be beta, again because of the property of a cyclic quadrilateral. So this triangle, triangle PAC, is equiangular to this triangle, triangle PDB. Hence these are similar. So triangle PAC is similar to triangle PDB, right? So the ratios of their sides is going to be equal, right? What can I say about these ratios? That PA divided by PD is equal to PC divided by PB, right? The ratio of their corresponding sides. So if I cross multiply, PA into PB is equal to PC into PD, right? PA into PB is equal to PC into PD. Similarly, if I consider these two triangles, let me change the color. If I consider these two triangles, right, when these chords are cutting inside the circle at this point P. Now this angle is equal to this angle. Why? Because these are vertically opposite. And this angle here, if this is alpha, then this angle will also be alpha. Why? Because if you look at this arc CB, it subtends angle at A at angle and angle at D. Angle A and D are 2 points on the circumference of this circle in the same segment. So this arc CB is going to subtend same angles at these 2 points. This is what we have studied already. Similarly, if you look at this arc AD, then this angle B beta and this angle beta will also be equal. So these two triangles are also equiangular, right? So what can you say about the ratios of their sides? That the ratio of their corresponding sides will be equal, right? So side opposite to beta is PA divided by side opposite to beta is PD will be equal to side opposite to alpha, that is PC, and side opposite to alpha, that is PB. Now if I cross multiply, I'll get PA into PB equals PC into PD. Right? Again, the secant property of a circle is proved. Okay. So what have I proved here? That if I take any two chords and these chords meet at a point P, whether outside the circle or inside the circle, then PA into PB will be equal to PC into PD, which is the secant property of a circle. Now look at one more thing. Now see, if P is any point on the chord AB or AB produced of a circle with the center O and radius R, then these two results will follow. Okay, so let us take this chord AB and another chord CD which passes through the center. CD which passes through the center O. Okay, now look at this. This is point P, right? According to the secant property of the circle that we just proved, what can we say about the product of PA and PB? PA into PB is equal to PC into PD, right? But in this particular case, what is PC? What is PC? If this is radius R, right? What is PC? PC is OP plus this radius R. So I can replace this PC with OP plus R, right? And what can you say about PD? PD is OP PD is OD minus PD. OD minus OP. And what is OD? OD is radius R. So I can write it like this: R plus OP into R minus OP, which is nothing but R square minus OP square. Now this point P can be outside the circle also. It can be outside the circle also. Let us take this chord AB like this. And chord C, which passes through the center, meets this chord at this point P outside the circle. Right? Let the center be O. Okay. And this is C, this is D. Right? Again, by secant property, I can say PB into PA is equal to PC into PD. Now see, this PD is OP minus this OD, which is radius, right? This is again radius. So I can replace PD with this PD with OP minus radius, and PC with OP plus radius. So if I multiply these, this is nothing but OP squared minus R squared, which is this result. So according as P is within the circle or outside the circle, these results will follow if P is any point on a chord AB of a circle with center O and radius R, right?